In this video, I would like to tell about the SFA, that is a small face attention face detector. Then we are going to see about the overview of our process. Okay, here we are going to detect the small face. Okay, first the performance of previous face detector deteriorates dramatically as the face scale screens. In this paper, we propose a scale invariant face detector named small face attention face detector. For better detecting small faces, we first present multi-branch face detection architecture, which pays more attention to faces with small scale. Then feature maps of neighboring branches is fused so that the features coming from large scale can accelerate detect hot faces with small scale. In our process, the main objective is to detect the small faces by using empty CNN. After that, we have to predict the model by using the deep learning convolutional neural network to enhance the overall performance. So this is our overview of our process. That is, main objective is to detect the small face from the input images. The input images contains a group of people. So in that group of people, we have to detect the small faces. Okay, now we are going to see the flow of our process. First we have to take the input images. After that, the input images was taken as output. We have to take the input images from dataset repository. After that, we have to implement the image extraction. We have to extract the features from the input images. After that, we have to implement the pre-processing step. In this step, we have to remove the unwanted noise from our input data. In this step, we have to use binary conversion, so the input images will be converted in the form of binary. After that, we have to implement the detection module. In this module, we have to implement empty CNN. In this module, performs the detect the small faces from the pre-processed images. After that, we have to prediction. In this step, we have to implement the convolutional neural network. After we have to predict the small faces, we have to implement the convolutional neural network for enhance the overall performance. That's why we have to implement the CNN model. The main reason for implementing CNN model is to give the better performance. After that, finally we have to implement the performance analysis. Under performance analysis, we have to find some performance metrics such as accuracy and validation loss, training loss, and so on. So this is the flow of our process. Now we are going to see the output part, that is demo part. We are running our process in Spider IDE from our Anaconda navigator. So this is our output part. Here we have to take the dataset into test and train. This is the binary images, that is this is the pre-processing step. We have to convert the input images into binary conversions. After that, we have this is the confidence name and key point left eye. Actually, the face detect based on eye, mouth, then these nose. So based on these organs, we have to detect the small faces. Just display the values for each faces. So this is the result for small face detection. So this is, we have to detect the small faces by using the empty CNN from an input images. The boundary was is calculated based on nose, eye, mouth. Okay, After that we have to implement the convolutional neural network. So this is the layer type and output shape for each layer. Then finally we have to implement the performance metrics in term of accuracy is 93.75%. So this is the validation graph for loss and accuracy. So this is the output part for a small phase attention phase detection. So this is the variable exploded. The variable exploded means in our process we are used some variables in that variables which are stored in this explorer. So that is variable explorer. So this is our output part. Thank you.